So now we're at the console of our Red Hat Enterprise Linux version 5.5 box. We're on Control-Alt-F1 or teletype terminal number 1. Let's log in as user root. And confirm our presence using the TTY command. Excellent, we're on TTY 1. Super, so now we want to upgrade the system. The thing to do is to reboot. The CD's already in, that's the boot CD that we've downloaded from the Red Hat Enterprise download repository online. And once we reboot, it will boot because our BIOS is set to boot from the CD-ROM first using that CD, which will provide us with the grub bootloader with options for booting the existing system, recovering the system, or booting a new installation. So let's go ahead and issue the reboot command, which is basically an init6. This will terminate services. Now here's our BIOS. Let's enter the setup using F2. This will allow us to confirm that the system clock is set to UTC time with respect to the Enterprise 6 installation, which will invariably ask us whether or not the system clock is set to UTC so that it can offset it accordingly. And that's the suggested thing for you to do, to set your system clock to UTC time for proper daylight savings adjustments by your operating system. Notice above F12 for Pixie boot. This allows us to boot from the wire if necessary. And after all the initialization of the storage back-end controller, we're in the BIOS. Now, it is set to UTC time 1533. The current local time is just about 5 hours prior. So this is UTC time. It's off by a few minutes. We can always modify it by pressing enter and navigating to the appropriate field. It's about 1542 GMT or UTC. The date is correct, and the system memory is relegated to 512. It's not limited for the OS install mode, but physically limited with only 512 megs of memory. The boot sequence, let's navigate, is set to use the CD-ROM first. This first slot here would be for a Pixie boot if it were checked, but it's not checked. And you can move things up and down by using plus or minus. CD-ROM first, hard drive second, and Pixie boot third if appropriate. So with that said, the BIOS looks fine, and we can escape the saved changes and boot from the CD-ROM. So now the BIOS is firing back up. The storage adapter will initialize. The embedded server management will also initialize. And this at this stage is an older PowerEdge server, but its processors are still rather nifty. The bus speed is slow, but the processors are still fast. Hard drives are initialized, 336 gig drives. And now we're booting from CD-ROM. So, this is for version 6. Now, to modify this grub menu, you press Tab. First, you highlight the option that makes sense, and then you press Tab. You may install or upgrade the system. You may install with a basic video driver, that's the VESA setting. You may rescue and install system, or you may boot from the local drive. This last option, which is present in other distributions, will allow you to boot any existing bootloaders that are present on the primary hard drive on your system. So for example, it provides you an out in the event that you need to boot the existing operating system. So these are your four options. To make changes, as we've mentioned, to the boot menu option, press Tab, and this reveals the string. So VM Linux, the Linux kernel, will load with an initial RAM disk of initRD image, and we'll tack on our settings using Linux repository set to what we've mentioned, 192.168.75.101/Linux CBT, and it is case insensitive since it's Apache server. Contents are stored beneath the top level EL6 directory, miscellaneous, rel6. So this is where the sources will be located during installation by Anaconda. If we neglect to specify this repo option, then Anaconda will prompt us at some point to supply the installation sources either via local media such as CD, DVD, or via the network via NFS, FTP, or HTTP. So it saves us some time by specifying it now. Now, graphical installation doesn't work, but we're still going to go ahead and specify the resolution in the odd event that it happens to pop up. We want to control the resolution with which the installer is displayed to 800 by 600. We also want to set the IP address to a fixed address since the server has a fixed address on the network. Let's also set its net mask to 24 bits and its gateway to the default router on the wire. Let's also set DNS in the event that it's necessary during installation, since we do have access to a shell during installation. So these are the settings that we'd like to pass to Anaconda, to the kernel that will be used for installation. There are a number of other settings, as we've mentioned. Just consult the Red Hat documentation and check online, since the Linux kernel supports myriad options during booting. So let's go ahead and fire this off. And we did so by simply pressing enter. VMLin is the kernel for installer, initial RAM disk with drivers to detect and support the connected hardware are being loaded. That's what all those dots mean. And now notice we're in a text-based installer. If you notice quickly, before the screen switched from the black screen to this screen, it read that there was not enough memory to support the graphical installation. As is traditional with Red Hat Linux, the option to test the media before proceeding with installation is made available. This is to avoid any possible ramifications of corruption at a later stage in the installation, such as the inability to copy RPMs from the CD or DVD to the hard drive, resulting in a broken installation, perhaps one that doesn't boot. If you are confident that your media are, in this case, it's one disk, proper and error-free, then skip the media check and move on. So this will take us to the next phase of installation. Network Manager is configuring ETH0, and notice the install image was retrieved. That means the network settings we pass worked. And if you notice again briefly, you do not have enough memory. So welcome to Red Hat Enterprise Linux text-based installation, because not enough memory was detected to support a graphical installation. So let's go ahead and press OK and indicate standard settings such as the language that we'd like to use, the keyboard, and now it's scanning for connected storage devices. And as we've mentioned, our system clock uses UTC, but our offset is -5, or GMT -5. So the offset is correct, America, New York. System clock uses UTC. If your system clock does not use UTC, which means it uses local time, then deselect system clock uses UTC so that the operating system does not switch your time to a wrong time when it's up and running. Time configuration takes place during the initialization of the operating system, and it's important that the option system clock uses UTC is properly set. Now this can be changed, of course, when the system's up and running, but it helps if you get your time settings correct prior to installation so that all of your file stamps and everything are appropriate. Let's go ahead and specify a password for the root user. This is a required step and can be scripted, of course, using Kickstart. And the navigation in the text interface is conducted using a combination of tab and enter. So tab to move between the fields and enter to commit changes. So as we can see, it sees that there's an existing Linux system. It also sees multiple hard drives. So we have some options here. We can use entire drive, we can replace the existing system, we can use free space. There is no free space on the first drive, so that would not be an option. The second drive, SDB, has free space which could be used. SDC also has space. But since we intend to upgrade, what we should do is use the replace existing Linux system option. That's the upgrade option. And now it specifies here that the partitioning options will now be written to the disk. In this case, it's going to replace the existing system. If you go back, you'll see the options. This is your opportunity to make changes. And we'll cycle through again, write changes to the disk. And notice that it's going through the stages of creating ext4 file systems on the file systems that were in place that were ext3. Again, existing files will not benefit from this extension. And this is progressing nicely. Because it's across the wire, at gigabit speed, the packages should be copied rather quickly. So it's just a matter of waiting for this to run to install all 219 packages. And during installation, as you've come to expect, there are a number of consoles available. Control-Alt F1 is where the text-based installation takes place. Control-Alt F2 is a shell that may be used. You can interact with it at any time, and you'll see whatever partitions that have been allocated thus far, such as home, for example, etc. Notice it's used logical volume management. uname A 2632 is the kernel that's being used, and that's on Control-Alt F2. So Control-Alt F1, installer, which is already at halfway. 2, console that you may use, which has remounted our environment in a way so it can place the files that are necessary to the drive. Control-Alt F3 shows us logging information. Additional logging information, Control-Alt F4. This is specific to the hard drives. F5 shows us step-by-step what's happened with the various drives and file systems. F6 is blank. And F7 ditto, since we're not using graphical. So F1 brings us, or returns us, to the installation. So there are a number of new changes to Red Hat Enterprise Linux 6, including, for example, the fact that the graphical interface is no longer on Control-Alt F7. It's now on Control-Alt F1 as the primary interface, which is a hint that the graphical interface is to be used as the default interface, whether server or desktop implementation. And we see it installing the SE Linux targeted policy package. enhancements to SE Linux have been made as well to cover more services, including SSH, for example. Notice the log levels, info for the steps that have taken place. Network Manager updated sysconfig network scripts, ifconfig eth0. And now we're on the final package. Notice during this text-based installation, we were not prompted to select package categories. Assumptions were made by Anaconda and have been carried out as a consequence. That's the default behavior, by the way. Let's navigate to F3. Preparing to install packages was the last message. SE Linux rules, number of rules, almost 200,000 rules have been applied. Grub was run to update the bootloader. And now the system has been finished. So if we reboot, this will take us through the cycle again. Now, of course, since the CD is in, it'll boot unless we eject it. Since the final or last option is to boot from the local hard drive, we can allow the CD to boot and then select boot from the local hard drive, which will then render boot control to the primary hard drive specified in the system BIOS that's responsible for booting a system. Either way, to play it safe, if you're performing this installation remotely, you should remove the CD at this stage, or have someone remove it so that the system boots to the appropriate option, since you're not able to change the grub boot menu on the CD since it's read-only. And here's that boot menu again. So let's boot from the local hard drive. And there's the 2632 kernel. And we'll let it go through and boot. Pressing escape will show you the different services as they are initiated. And now our system's up. So we've performed the installation. We can log in. We didn't configure the graphical environment. Run level is 3 as a consequence. Uptime is less than a minute. DF indicates the current layout, which means it reflects what we've discussed, which also means it's a result of logical volume management, which is why it's able to achieve the 50 gigs. So from the storage that's made available, it was able to allocate the appropriate storage. So that is one way to perform a new installation of Red Hat Enterprise Linux version 6 using HTTP sources served by Apache and a boot CD-ROM with some boot options across the wire.